Okay, we're in chapter 2.6, Special Systems of Linear Equations, and we need to review real quick. We've got some options. A system of linear equation can have one solution, no solution, or infinitely many. So, let's show you real quick one solution. And we'll explain that as we go because you might not remember. One solution is what happens when you have a graph with two equations that cross in one place. So we have a graph with one equation and another equation, and that other equation happens to cross the first one. And that's a system. It's a system because there's more than one equation, and it's trying to find the solution. It's the one place that's true for both of them. So this point on this line, which this point could be like negative 2, 1, it could be the same for both lines. And it's the only place where it's the same for both lines. This is called one solution. Another option is no solution. And this is the case where we have a similar experience where we're graphing two lines, but in this case, this line has a particular slope, and another line, instead of crossing it, it has exactly the same slope. And that happens occasionally. It could be that this is like, and this one kind of looks like over 1, up 1, over 1, up 1. We can see the slope is the same. And we got the same thing here. Of course, it's not drawn perfectly, but the slope is the same, and you get the idea. The third option is infinitely many. Yeah, that was right. Infinitely many, come on, solutions. Okay, and this happens when you have a line that ends up looking exactly like another line. You have two lines. They don't look alike until you graph them, and then after you've graphed them, you can see that this one looks like this, and then this red one looks like this, and they basically are one over top of the other. In fact, they are. They're not basically. Every point on each line is the same. And since lines travel forever in both directions, then this line goes forever in that direction, and both of them have every point has the same number of solutions, or has a matching solution. So those are our three options. One solution, which is ones that we work with most of the time, at least in this book. This is what you're going to see, but we occasionally have something crop up where there's no solution. Is because it could be because they're parallel and they never cross, or you could have this other problem where every solution is the same, and it's because they're really the same line. They just look different. So I'll show you what that looks like. I'm going to do a couple real quick. This one is for parallel lines. Parallel lines have no solution. Let's try that again. No solution. Okay, so this is what we think we're going to get, and I'll show you why. We have y is equal to 3x plus 1, and y is equal to 3x minus 5. All right, and if we just draw a quick graph here, boom, boom, and then we just kind of work through this. The slope here, I keep forgetting to switch back. The slope is equal to 3 over 1, which, and the y-intercept, this is the slope right here. You guys remember that. And the y-intercept is this plus 1, which is b, is equal to 1. And so we're going to start at 1. Maybe I should change colors now that I've written on it. I'm going to start at 1, and our rise is 3 and our run is 1. So we go up 3 and we run over 1. So the first point is going to be here. And if we were to just draw this line, usually we want to do it twice. If we draw this one, that's part of the reason we want to do it twice. Let's do it again. We're going to go up 1, 2, 3 more and over 1 more. So that point's going to be about there. And the reason we want 3 points is because 3 points line up a lot better than 1 point does. Try to get them to line up is with a ruler works a little bit better. Okay, so this is our first equation, and our second equation, if we go back to red, we have the same slope. And we probably could just quit right there because the slope is 3, 1. By this time our y-intercept, b, is equal to negative 5. So it's going to be exactly the same line, but instead of starting at positive 1, we're going to start at negative 5. So we're going to go down here 1, 2, 3, 4, negative 5. Maybe I should switch back to that green color. And that's our first point. But we still go up 3 and over 1. So 1, 2, 3 over 1. 1, 2, 3 over 1. And we should have the ability to draw a line that is pretty close to parallel to the one that we just drew. If we had some better graphing skills, you'd see it one that's even more so. Okay, so the next one is going to be where what happens when we come up with the same one. So this is going to be infinitely, I got to make sure I change that, infinitely many solutions, and I always have to check to see if I'm doing that right, because I always think that that's spelled wrong. Infinitely many solutions. Okay, all right, infinitely many solutions. First one, here we go. Equation number 1 is y equals negative 2x plus 4, and the second equation is 4x plus 2y is equal to 8. And we could just try to simplify this equation, but just for the fun of it, because you need to see more and more of these. The slope here, m, is negative 2 over 1, which means that it's going to be a negative slope. We're going to go down 2, because it's a negative 2, we go down 2 and over 1, and our y-intercept is at 4. So b is at 4. And we just go ahead and grab another color. And so we got 1, 2, 3, 4, 0, 1, 2, 3, 4. Y-intercept is at 4, but our slope tells us we go down 2 and over 1. Down 2 and over 1. And so we can draw this line. Now when we get ready to start working on the other one, this is negative slope, and I guess we can see that our we go down 2 and over 1. Down 2 and over 1. Kind of see that. We start working on this one. We can see right away that there's sort of a problem. It doesn't look like this one, and we usually like it to be in this y equals mx plus b, or the slope intercept form, and so we go ahead and we start working on that. So we're going to subtract 4x from both sides to make that look better. It ends up becoming 0. We have 2y is equal to negative 4x plus 8. You can see that I sort of slid the 8 over and put the negative 4x up there because I want it to be in this form. And now we have next step is to be just to divide everything by 2, because we don't want that y to have that integer in front of it. We just want to have just the y there by itself. So we're going to divide everything by 2, which would be the next proper step. 2 halves is 1, so we just have y. And negative 4 halves becomes negative 2, because negative 4 over 2 is negative 2 over 1. It's the same thing, x. And then 8 halves becomes 4 ones plus 4, and voila, we see that y is equal to negative 2x plus 4 is the same as y is equal to negative 2x plus 4. We could have just jumped right to that by noticing that this one is not in the correct order and trying to fix it up. Alright, that should do it for you. You basically have to do a lot of those this time, because you're looking at these special situations where there are either infinitely many solutions, like this one, where they're the same line, and if I were to draw this other one, this line would look exactly the same, and we wouldn't be able to tell them apart, and they'd all have the same points in common. Infinitely many solutions, or that other one that we did where it was two parallel lines. And so two parallel lines is wonder if I can make that screen bigger. I start to, this little tool I have, oh, I can make it smaller. Well, apparently I'm fading away into nothingness. So you have, oh, that's bigger. I don't know what I'm doing, but we're going to stop. You just enjoy yourself, get your homework done.